Sorry, my Danish is not as well developed as your Danish, I'm afraid. So we're going to do this in English. Is that okay? If you don't speak English, raise your hand. Did anyone get the joke? It took a while, but no, clearly it didn't work so well. So I'm actually really excited to be here because I believe that architects are the critical, pivotal role in basically every organization and company, because it's the architects that have to translate the business side of the house to the technology side of the house. That's typically what architects do, right? Yeah, especially enterprise architects, as I understood. I have several in the room. And that's important to be aware of, because what I'm hoping to do in the 1 hour and 15 minutes that I have is to basically lift up the discussion a little bit and take a step back and look at what is actually happening in society, what is happening in industry, what is happening in technology, and then basically reflect on 5 different aspects that I'm going to come back to. Now, I have way too many slides as usual, so I propose that rather than me trying to get to the end of my presentation, we try to make this interactive. Okay, so if there's at any point you disagree with me, or you have a question, or you want to discuss, you just stop me and we'll dive in at that point. Okay? I'm not in Sweden. In Sweden, disagreeing with someone is really frowned upon, you know, the Swedish consensus culture. But I'm in Denmark, so I don't have to worry about that, right? I mean, it's much closer to the Dutch culture. In the Dutch culture, basically, we say if 2 people have the same opinion, one of them doesn't need to be there. So I think that's the approach that, yeah. So that's the approach that we take. Oh, sorry?
We're gonna walk out right now, all of us.
Well, I do that at 12:15, okay, and then we'll take it from there. So the question basically that I wanted to discuss is, or the controversial title. IT provocateur was what I thought I heard, but why digitalization will kill your company too. And I wanted to start with that. If we look at the Fortune 500, the 500 largest companies in the world, of the companies that were on that list in 2000, how many of those companies were still on the list in 2014? Does anyone know the answer to that question? Very good. More than half of all the companies that were on the Fortune 500 in 2000 were gone in 2014. So, and that is a very interesting development. What is happening is that companies are increasingly rapidly being disrupted these days. And why is that happening? What is the thing that is driving this? And if you look at this fine gentleman, yeah, this fine specimen of the human species gives us an indication of what it is that is going on. Yeah? Does anyone know this guy? You know, you use a product that he invented daily. Sorry? No. This is Douglas Engelbart, the inventor of the computer mouse. I guess you use a computer mouse, right? Just for the record. Yeah? The digital revolution is far more significant than the invention of writing or even printing. Yeah? So imagine what this means. The history of mankind fundamentally shifted with the introduction of writing or printing. And what this guy says is that what we're now in the midst of, the digital revolution, is a much bigger thing than those 2 things that happened many thousands of years ago in the past, or hundreds of years. Yeah? And we can see this because companies are being disrupted because of digitalization. The average tenure on the Fortune 500 is now down to 10 years. And the main cause is why this is happening is because companies fail to innovate and build new core capabilities. Digitalization is now the big disruptor. And you know, as software architects, you're smack in the middle of the digitalization journey for the organization that you work for. Yeah, so very quickly through definitions, digitalization is the use of digital technologies to change the business model and provide new revenue and value producing opportunities. It is the process of moving to a digital business. Yeah? If we go to Boston Consulting Group, just to stress this a little bit, yes, it is about adding software to products. It is also about pure software products. It's about data-driven and digital services. And R&D plays an important role here, but it's also sales channels and marketing. It is manufacturing supply chain, and it's HR, finance, and support. And yes, of course, we need to go agile. That's a given. I'm going to come back to that. But it's also about platforms. It's about analytics and data integration. And it is about our digital partner ecosystem. This change that we are in the midst of, yeah, that all of us in this room have built a career on top of, is touching everything in the organization. And the companies that do not manage to take into account all those different aspects are the ones that are going to go the way of the dinosaurs. Those are the companies that get disrupted. Yeah? So, you know, I know Danish architects, the partying kind, I suppose, right? Yeah, see? So what I thought is I keep it really simple. I have 3 takeaways for you guys. So the first is digitalization. We're just at the very beginnings of this. We've barely scratched the surface. There is a lot more coming. Second, companies are moving to what I call a new digital business operating system. That digital business operating system is organized around speed. So every company I work with is moving towards continuous deployment. It doesn't matter if it's software subject to functional safety or certification or whatever. Every company is looking for ways to get to continuous deployment. Yeah? Because once I get to continuous deployment, I can also get data back from my customers and my products in the field. And when I get that data back, I can use that data for AI solutions, machine learning and deep learning, and I can use it to empower my teams and provide much more autonomy to teams. And we're going to talk about those different things. And then finally, we are not an island. No company is an island. Yeah, you're part of a business ecosystem. And what we're going to be talking about is how should you relate to the business ecosystem around you and figure out ways on finding the best ways of partnering with your ecosystem. Yeah, so that's what I was hoping to share with you. Do you feel that that's relevant content? Yeah, or do you think I should go? I have hundreds of other presentations on this computer. You just, you know, the relationship we have in the coming 1 hour is the relationship I have with in a permanent state with my wife. When she says jump, all I ask is? Exactly. I'm glad that we're all in the same situation here. So here's what I'm going to do. I'm going to first give you a bit of background of who I am and where I come from. Then I'm going to talk about trends in industry. What do I see happen? Then I will move to what I call this new digital business operating system, which for me has 5 dimensions: speed, data, AI, empowerment, and ecosystems. And by that time, we'll get to conclusion. Once again, stop me anytime, yeah, if you have questions or you want to discuss. So very briefly about me. I used to be a young and innocent professor of software engineering in Sweden and the Netherlands. I'm originally from the Netherlands. Yeah, but in the early 2000s, I get a call from a company called Nokia. Do you remember Nokia? Yeah? That's exactly what I'm currently trying to avoid, this fate of Nokia, with the companies that I work with on a regular basis. I mean, basically, Nokia, of course, didn't do so well, right? So, but I ran the Software and Application Technologies Lab at Nokia Research Center for several years. And then in 2007, the same year as the iPhone was announced, I wish I could claim causation. I can only claim correlation for the statisticians in the room. Yeah, I got a call from a company called Intuit. You haven't heard from Intuit, I think. Intuit is a 8,000 person company based in Silicon Valley, around 4.5 billion in revenue and 50 million customers, almost exclusively in the US. Our internationalization strategy never worked really well. So I worked there for several years, and then since a few years I'm now back in Europe. I'm in Sweden. I run something called Software Center. I run a small consultancy where I work with a variety of different companies around the relationship between business strategy and R&D strategy typically. And I'm involved in a number of startups as angel investor, board member, or advisor. So if you're planning to start your company or you have already started your own company, come and talk to me afterwards. We never know if we can do something, right? Was that funny? No, not really. Clearly not. What I think is more interesting for you is that I run something called Software Center. Software Center is a collaboration today between 12 companies and 5 universities around improving the digitalization capability of the European software-intensive systems industry. We have companies like Tetra Pak and SAP, Siemens, Bosch, Qualcomm is an SME in the Gothenburg region, CEFT is China Europe Vehicle Technologies based in Gothenburg, Axis Communications is now part of Canon, they do web security cameras, Volvo Cars, Volvo Trucks are in there, Jeppesen is in there because they're part of Boeing, so we have Boeing in the Software Center, and then Ericsson and then Grundfos, the pride of Denmark, right? Everyone goes like, ah. Yeah, so... and we're talking to a few other Danish companies as well, by the way. So we're actually looking to take over Europe with this collaboration. And our goal in Software Center is fast, continuous deployment of customer value. Think continuous deployment. We look into a bunch of different topics. If you want to know more about it, come and talk to me afterwards. Continuous delivery, so continuous integration, continuous delivery, and continuous deployment. We look into architecture, technical debt, interface management, API management, etc. Metrics, yeah, the person leading this team has worked with Ericsson to create a complete factory of 1,600 metrics that all go into a big hopper, and every stakeholder can get their view on his or her relevant metrics out of it. Yeah, we have a theme on customer data and ecosystems. We look into autonomous systems, Internet of Things, so those are the kind of topics. And the biggest, newest topic that we're now starting to look into is software engineering for AI. Yeah, because it turns out that if you build machine learning and deep learning solutions, the software engineering challenges around that are actually pretty profound. We do not only work with what traditionally were metal bending companies. We also work with companies like Booking, a Dutch startup that I'm proud of, Spotify, Rovio, the company behind Angry Birds, Klarna, you know them, are they used in Denmark as well? Yeah. One of the Swedish prides from a startup perspective. King is the company behind Candy Crush. Yeah, you know Candy Crush? 300 million players, and still I have to meet the first person that admits that they play Candy Crush. I don't know why that is, but it's funny. Yeah, and then finally we've had several PhD students work with Microsoft and the data analytics team, so we partner with them around A/B experimentation and those kind of topics. Yeah, so that's who I am and where I come from. So that's the background. I work with a lot of different companies, so that's what I think is important. So what do I see happen in the industry? Here is the interesting thing. If you look at the Gartner hype cycle, technology hype cycle for 2018, then one of the things that you'll notice is that almost every topic on that list is driven by software. Yeah, if you go to this one, yeah, the first thing that I do when I get out of bed in the morning is I brush my teeth. How do I brush my teeth? I use an Oral-B electric toothbrush. 2 years ago, Oral-B announced a software ecosystem for toothbrushes. I'm not kidding. They put Bluetooth in the toothbrush with a few sensors. The Bluetooth talks to your mobile phone, and your mobile app will give you feedback on the quality of your toothbrushing experience. Yeah? That's how far software has come into our lives. If you look at logistics, infrastructure, sports, agriculture, forestry, electricity generation, telecommunications, cars, even garbage collection these days is driven by software. Yeah, there's a startup in Finland called Enevo that we visited 2 years ago, I think. They put ultrasound sensors in those big recyclable waste bins with a 2G connection. Once an hour, the sensor takes an image of how full is the waste bin. You know, you have those big boxes that get picked up by trucks. And then the garbage collection company can do a dynamically planned garbage collection route, which gives the company a 50% reduction in garbage collection costs. Even that stuff is now driven by software. Self-driving cars, software. Robots, software. Drones in the military, software. Even the most backward industry, construction, there is nothing worse than construction from an efficiency improvement perspective. Yeah, according to a recent Economist article, construction has seen 0% productivity improvement since 1947. Do you know how hard it is to not see any productivity improvement for 70 years? That's almost impossible. Then you have to hate technology so much that you do everything you can to adopt anything of it, right? Even that industry is now being dragged into the 21st century with 3D cement printing, automated bricklaying, and a bunch of other technologies. Yeah. The question, however, is why is everything moving to software? And this brings us to the cycle of innovation. Because if you look at innovation, the idea is you have an idea. You've all read the Lean Startup by Eric Ries, I suppose. Yeah, based on that idea, you build something. Out of that comes a product. That product you can put in market, then you can measure. Out of that measurements come data. From this data you can learn, and from those learnings you get new ideas. The faster you can go through this loop, the more innovative you are. So let's look at automotive for an example. A car platform typically lives 10 to 15 years, which means I go through my build, measure, learn loop once every decade and a half. That's a pretty slow learning cycle. I think we can agree on that, right? If we go to a car takes around 3 to 4 years, which means I go through my build, measure, learn loop once every 3 or 4 years. At this point, Volvo Cars has 36 months as their end-to-end plan for developing or designing a car. Yeah? So I go every 3 years through a build, measure, learn loop. But what about car software? Well, car software can be deployed into the car every day or every week. Yeah, I can continuously get new software into my car. Yeah, if you look, Tesla is already doing this every other month, basically. They deploy a new version of the software into the car. So if I have this, I have innovation cycles for software that are 100, 200, maybe even 500 times faster than any other technology that I have. That's why everything is moving from mechanics and electronics into software. Because software allows us to innovate at speeds that no other technology allows us to do. Now the question to you is, are you making use of the opportunities that you are given through software to drive your innovation processes? Or do you still have yearly release cycles or 6-month release cycles? I see a few nods in the room. Yeah, I thought as much. Yeah, but we can see this happen because if you look at the size of software in typical systems, this is a graph from a number of Germans that did this for vector consulting, then you can see that depending on the industry that you're in, the size of your software goes up with an order of magnitude every 5 to 10 years. And if you have a set of solutions, architectures, tooling, ways of working, etc., that work for building a 1 million line of code system, they typically don't work when you're building a 10 million lines of code system. And the things that work when you're building a 10 million lines of code system, they don't work when you're building a 100 million lines of code system. And now I can see all of you think, who builds a 100 million lines of code system? Guess what? Automotive does. A modern car has around 100 million lines of code in the car. If you buy the new Ford F-150, you know, the pickup truck that you can sell in the US, buy in the US, according to Ford, they went out with a big ad. According to them, depending on the model that you pick, there will be between 100 and 150 million lines of code in that car. That's the challenge that we have. So if you look at your situation and you're building a million line of code system, prepare yourself for having to deal with 10 million lines of code 5 to 10 years from now. Yeah, because that is the general trend that I see in the industry. It basically, the size of the software follows Moore's law. That's basically what I can see.
About the numbers of errors in that code.
Yes. not in my code, in your code, right?
My car.
Yes. And the interesting thing is, I run a workshop series started by Zenuity. Zenuity is a partnership between Volvo Cars and Autoliv. You know, Volvo Cars and Autoliv is a tier 1 supplier. We ran a workshop series, we're still running it, continuous deployment and FUSA. FUSA stands for Functional Safety Assessment. Yeah, so in automotive you have ISO 26262, which is a safety standard that determines that your car is safe and can go on the road. And what we're now basically working on is a agile version of how do you work with software that is subject to functional safety and you can still do continuous deployment. It's happening. It's already today happening. Yeah, so just get ready for that future. I think it's important to realize that. You look worried.
Shouldn't
I don't know. I don't think so. I think we're actually doing okay. So he has a car without software, right? Yeah, so. If we look at data, it's very hard to find numbers. This is one reference that I found that 50 terabytes of data is created every second. I think that's a gross underestimation. A single self-driving car generates 16 gigabytes of data per second. Yeah, because you have multiple cameras in the front, stereo cameras, you have a camera in the back, you have radar around the car, you have LiDAR, you have ultrasound sensors for near low speed engagement, and all those sensors generate so much data that it ends up at 16 gigabytes per second. That's the kind of systems that we're talking about here. And if we now go into what humans do, over the last minute, you know, 204 million emails were sent. Yeah, just to give you a feel. Yeah, if you wonder why your kids never stop watching YouTube videos, it's because every minute 72 hours of YouTube videos are uploaded to the internet. Yeah, if you're in the dating scene, yeah, I've heard of this thing called Tinder. I'm not sure, is that used in Denmark? No one will admit to it. That's funny how it works. I've been explained that you can swipe left or right, and I don't know what it means. I think it means like or not like, but I don't know. Over the last minute, close to 500,000 swipes took place. Yeah? So look at all the data that humans are generating. And then think of the next step. 50 billion connected devices according to Ericsson by 2022 or 2025. The amount of data that the devices around us are going to be generating will be vastly outpacing what humans are generating in terms of data. Yeah, so we're really moving towards a data-driven world, and I think it's important to be aware of that. That leads to the next thing, which is deep learning. I'm not going to go deep into this. Is anyone here experimenting with machine learning and deep learning models? There are a few hands going up. So if you're interested, I will come back to it. There's a company in Stockholm called Peltarion, which I'm on the board of. They have a super cool platform for deep learning solutions that you can very easily experiment with, graphical user interface. You can draw your models and then test it with your data, etc., etc. So go and sign up and do a few of their tutorials. If you don't know this technology, it's super cool and it's going to be an important thing. So just to put things in perspective, we started with AI in the 50s, you know, the things like chess and checkers. Then in the 80s and 90s and early 2000s, it was mostly machine learning to reduce, for instance, spam filters. And then now it is all about deep learning. And deep learning is typically concerned with convoluted neural networks, recurrent neural networks, etc., etc. Why is deep learning happening right now? We have the data. Yeah, do you know how hard it is to find a data set of 10,000 images or 100,000 images? Those are now available. We have the computing power because of GPUs. We have algorithmic improvements and we have much better tooling, although I think that TensorFlow and PyTorch and others are still pretty much code-based. There are much better solutions out there these days. Yeah, but if this guy, Sergey Brin, this president of Alphabet, says that the new spring in artificial intelligence is the most significant development in computing in my lifetime, that's saying something. There's a lot happening there. Final trend, need for speed. Here you see 4 products. Quicken is a personal financial management product by Intuit, eBay, Facebook, and Angry Birds. Each of these products were introduced roughly 10 years apart. Look how long it took them to get to 1 million and 50 million users. Yeah, so Quicken, it took us 6 years to get to 1 million users. We never hit 50. 10 years later, eBay is introduced. 30 months to 1 million, 80 months to 50 million. 10 years later, Facebook comes along. 10 months to 1 million, 44 months to 50 million. And then only 5 years later, Angry Birds comes along and they hit 50 million users in about a month. They don't even know how long it took them to get to 1 million. It just flew past. The lesson from this graph is, if you put something valuable in the hands of customers, adoption will be faster than always, than ever. Yeah, and you see that the time it takes for technologies newly introduced in society to get to 50 million users is constantly shrinking. Society is moving faster. And if you work for a company that has been dragging in terms of adopting new technologies and new approaches, you're really setting yourself up for disruption. And as an architect, you know, you live between business and technology. It's really your responsibility to warn the company for that, I believe. Now, if you don't like customers, but you like money, here's another example. Is that a joke that works in Denmark? In Sweden, it doesn't work. Sorry, go ahead.
If you go back one slide, I'm a bit unsure whether you can compare entertainment with buying and selling stuff, and I don't even recall what Quicken was, something foreign financial thing. So I think this slide is not really valid.
Yeah.
It says the less usable your product is, the better you are.
So I can definitely agree how you can have an increase in transition in society, but I don't think that slide shows that at all.
Good. But we agree on the point. That adoption of new technologies is faster than what it was in the past.
Yeah.
Good. Uh-oh, now I have to leave because we have 2 people in the same room that think the same thing, right? So, in any case, thank you for the feedback. Yeah, so here we go. If you don't like customers but you like money, here's the other one. I have a product that I sell at $1 billion a year. Most companies express their R&D budget as a percentage of revenue. So I put it at 10% of revenue. That gives me a $100 million R&D budget. Yeah? In Sweden, I always have to explain the math because we have some issues with our math education, but I assume that in Denmark that's not necessary. Is that a fair statement? Yeah? Good. My new product development cycle is 12 months, and I'm going to give you 2 alternatives. The first alternative is we're going to do everything we can to become more efficient. Yeah, and that means I'm successful. I'm 10% more efficient. I still ship after 12 months, but I only spent $90 million instead of $100 million. That's pretty cool, right? Even after taxes in Denmark, yeah, which are about the same as in Sweden, I think, yeah. That's a nice chunk of change where I come from. But here's your second alternative. I'm going to focus everything I can on reducing my development cycle. So rather than starting to sell my product after 12 months, I am 10% faster and I can put my product in market after 10.8 months. And assuming I'm not cannibalizing any existing products, and assuming I'm selling at a flat rate of $1 billion a year, I'm adding $100 million of additional top-line revenue to the company. What would you rather have? 10 million in savings or $100 million of additional revenue? I'm waiting for the typical response that I get when I present this slide. The typical response is, I want both. But I wasn't offering that, yeah? Yeah, but look at this. You have earned back your entire R&D budget just by being faster. There's nothing that you can do from an efficiency perspective that will outperform cycle time improvement. Just nothing. Yeah, and not only that, just a second, then I'll let you in. What happens in companies that focus on efficiency? They put all kinds of milestones, reviews, board approvals, and other things in place in order to make sure that nothing inefficient will ever happen in this company. By extension, nothing at all happens in the company. When you focus on efficiency, everything gets slowed down. What happens when you focus on speed? When you focus on speed, you look for every activity that is on the critical path between you and being able to sell. And you look for ways to automate it, do it in a different way, get it off the critical path, and do other things in order to only do the absolute most value-adding activities that you absolutely have to do. So by focusing on speed, you actually become more efficient. When you focus on efficiency, you get slowness as a byproduct. Yeah. So if there's one takeaway from this, focus on speed, and you will be, you will lose weight, look better, and be more fabulous. That gentleman was first.
But from an IT perspective, I don't give a damn. See, because if I save 10 million, that's 10 million extra that IT has to work with.
Yeah.
If I add 100 million to the top line and I get 10%, that's also 10 million.
Yeah.
So the IT department doesn't have any incentive. To me, it's 10 million or 10 million.
Yeah.
I don't care.
And this is, I think, the interesting point. As an architect, I believe that you have a responsibility for the end-to-end organization and not just for the IT department.
But the incentive structure inside the organization is typically so that the business owns the benefit, but IT owns the cost.
Yeah.
Which means that IT has no motivation to add the speed.
Yeah.
So as an architect, I can't sell this idea to IT because they wouldn't care. I have to sell it to the business.
Yes. Okay. That's, I think, the key point. And for me, architects are the people that live on the interface between business and the technology and IT side. There's a gentleman in the back. Yes, sir.
Yeah, is that also why I have a smart TV that I can throw out after about 1 year because it's not being updated anymore? Move on to the next product. It's in the trash.
Yeah, so that's now we're getting into a very interesting discussion. When I was, the first time I moved to Sweden in '94, I brought a television along with these glass tubes still in it. It was that old. I was dying for that TV to break because I wanted to have a more modern flat screen TV, but that thing was still working. And as a Dutch, we're a bit on the cheap side. So buying a new TV while the old one was still working didn't feel so good. So what we see is that indeed many consumer products are now being planned for planned obsolescence, but there is a countering these days happening where you see that when products are offered as a service, they basically start, and this is a much longer discussion and I haven't even gotten into the content yet. What is now starting to happen is that car companies are starting to explore a model where the mechanics will live for a very long time, maybe even 30 years, the basic chassis of the car. The electronics get updated every couple of years maybe, because you run out of space to install new software. Yeah, so the electronics and some of the sensors get replaced on a regular basis, maybe every couple of years, and the software gets updated every couple of weeks. So what you're trying to do is, rather than when you move from I sell a car to I offer mobility as a service, you look for ways in which the most expensive parts you can keep around the longest. So we're moving away from this throwaway culture, I believe, because of the transition from products to services. You disagree?
No, but
Oh.
yes, actually I do. because,
See, I knew.
I mentioned that in my company I try to say we should move slow in order to move fast. And the reason for saying that is that I think it's very important to reduce technical debt, upgrade all the software, etc., etc. And some of those things in the focus of being so fast all the time, just ship feature,
Yeah.
actually end up being very slow, and you have a lot of technical debt, and
Yeah.
business people have a hard time understanding the domain of IT. So I think
Yeah.
that's
But now we are going to get to something. You know, I've been a professor of software engineering for more than 20 years now. I wrote a book in 1999-2000, before you guys were born, right? Which was, which had the title Design and Use of Software Architecture. And what I said in that book, which was the wisdom of the late 90s, as architects, we have to be really careful to carefully design an architecture before we start the development of the system, because once we commit to a certain architecture, changing it will be extremely expensive and difficult and almost impossible, and it will never happen. Yes? I wrote that, and many other people wrote that in the 90s, yeah? So I'm guilty, but I wasn't the only one who was screwing up on that front, yeah? That was the wisdom in software architecture in the late 90s and early 2000s. And then Agile came along, and what we now see is that we manage architectural technical debt. I have a few slides on architectural technical debt out there later in the deck. We now manage architectural technical debt as part of the normal Agile process. Teams have 3 jobs: build functionality, new features, fix defects, and realize architecture refactorings. And the relative allocation of resources to those 3 things becomes a business decision in an enlightened organization. Now, in practice, there are 3 types of organizations for managing technical debt. The first is organizations that don't understand technical debt, and then as an architect you are forced to hide architecture refactoring in feature development. Yeah, product management comes up. Yeah, been there, done that, right? Product management says, I want this feature, and you go, oh, I can actually slipstream some of these fixes in there. And then you go to product management and you say, oh, it's going to cost you this much. And product management goes like, that much? And you say, yeah, it's complicated, you know, we have to change some things here and there. And then you basically hide your refactoring in there. Phase number 2, you have an enlightened CTO or CIO. And that person basically says, we have fixed allocations for feature development. If you go to Axis, until very recently, their CTO said 50% of R&D resources go to feature development, 25% go to defect management and quality, and 25% go to architecture refactoring. Non-negotiable. Dear product managers, you can only allocate the 50% for feature development. Yeah, and then the third model is when you have an enlightened organization, when you dynamically shift up and down the relative allocation of resources to those 3 activities, depending on where you are in the business cycle. Yeah, sometimes you have to push a product over the finish line, and you basically invest a little bit more into features, and then after you ship, you actually deal with some of the quality and architecture debt that you have accumulated during that sprint. Yeah, so that's the thinking, but of course it needs to be done. Because we have lots of research that shows that most companies that don't manage technical debt, and dear architects, this is part of your job, yeah, is where the debt goes up and up and up until we reach a point that it's impossible to do any feature development anymore, yeah, because everything you touch in the system basically causes stuff to break all the time. And then you basically push the fire alarm and tell to the business side, we need to improve the architecture of the system because this is not working. And then you get some time to clean up the architecture, so technical debt goes down, and then everyone goes happily back to doing feature development, and technical debt goes to the roof. Sounds familiar? Yeah? So the problem is you're paying for technical debt management anyway. You just do it once every couple of years for 6 months. Nothing comes out and you just fix technical debt. or you have a constant, sufficiently high investment in technical debt management that allows you to be productive at all times. Yeah, sir.
Putting this across the table to the guys paying for the party is
Yes.
usually hard.
Yes.
They like the words and they, yeah, I agree, but once they, see the bill, they say, I'll think about it and I'll take the cheaper version.
Yeah.
Is there any literature, anything that supports these arguments that I, as an architect, could bring into such a discussion?
Yeah. So there is, if you Google architecture technical debt, you will find there are a number of books that are out there. One of my PhD students, then postdoc, now associate professor in Oslo, has done all his research around technical debt. We have research that shows that on average, R&D teams spend 24% of their resources managing or dealing with technical debt, or have inefficiencies because of technical debt. So we have lots of data. And if you drop me a note, I can put you in touch with Antonio.
Thank you. I think the guys that I would be talking to, they wouldn't want something from a university. They would want a business that was, very successful because they took the pain of architectural refactoring along the way.
Yes. So then what the work that we've done is in the context of software centers, so those 12 companies. So that helps a little bit, I hope.
Yeah.
And the other one is that people are fundamentally driven by two factors, fear and greed. Yeah, so I often use the fear slide. I mean, if you don't do it, then you go the way of the dinosaurs. That's where I started the discussion. Make sense?
Yes.
You were waving at me, sir.
But why not just do it as the first option you said? So just put the technical debt, fix it in the features at the same time. Because nobody else cares and you know where it goes. It works.
Yes, it works.
It's no, it's part of the job. It's the same thing to say, I don't have to test my code, someone else will test it. No, you have to fucking test your code.
Yeah.
That's the same. You have to do your own refactoring.
There's a remark in the back.
The problem is that sometimes the refactoring is basically a huge amount of time costs that much basically work from you. So you cannot sell that idea to your customers. Something in their opinion should take maybe 5 hours, now you're saying it will take 100 hours. So definitely not. The problem is, I think, that you have a group of people in the business having the money, and then you have the other group having the brain and the good ideas about how to do it. If you combine these two, then you will have a good result.
Yes. So what I see in many companies that I work with is that we're moving away from the traditional hierarchical and functional organized businesses here in IT or R&D is there to much more of a cross-functional teams. And if you allow me to get there, I have a few examples. There was someone here waving as well. Was it you?
Yes, I've had the good fortune of working at a number of companies where technical debt is actually recognized and accordingly to. And the main advantage is that it's communication between the IT department and the rest of the business becomes more transparent. So, I mean, if you have to hide these things in feature development, for instance, first of all, it makes it hard for you to actually figure out how much is this. I mean, because technical debt is something that you sometimes don't know how long it will take because you don't know how deep you need to go. And then if you don't prepare the business for that, then you get into a situation where the feature development drags out even though you're not even working on the feature because you're actually working on technical debt. And that becomes a very problematic stance or position to tell the management.
Yeah.
So transparency is just a better option in my opinion.
Yeah, I agree. Sorry. Yeah, and you, and then I will keep going.
I think transparency is a good thing, but the problem is often that you have different people from different worlds. So it's kind of hard to convince them about it because it requires a technical knowledge or some depth in order to understand the reason why you're suggesting doing things in a certain way.
I don't agree that you don't need to have any technical knowledge. You need to trust your team saying, this will cost you a lot of money if we don't do it.
Yeah.
But
Then you don't need to know why you need to.
Okay.
Subject.
I propose that you take this as a subject in the afternoon discussions. Is that fair?
Excellent.
Yeah, good. I'm going to talk about 5 aspects now: speed, data, AI, empowerment, and ecosystems. And I have half an hour left, and I'm the only thing between you and lunch. I'm just reminding you, right? So, at least I think I am. Yeah. I have a very simple model. The 3-layer ecosystem, the 3-layer product model, which basically says every product, every system, every product portfolio has 3 layers of functionality: a commoditized functionality, a differentiating functionality, and innovative and experimentation layer. Yeah? This is stuff that you need for your system to work, but no customer is going to pick you over a competitor. When you picked your new mobile phone, the fact that you could make calls with that mobile phone did not factor into your buying decision. You would have been really annoyed if you couldn't make calls with your new mobile phone, but it doesn't differentiate the phone anymore. Then there is a layer of differentiating functionality. Nokia recently came out with a camera, a phone with 5 cameras on the back. I don't know what you do with those 5 cameras. I think it's for 3D, whatever, but they consider it differentiating. And then on top of that, you have an innovation experimentation layer. The way it works is I try out 10 things up here. Then I find something. Typically success rate in innovation is like 10 or 20%. One of those things really resonates with customers, so I productize it, I put it in my differentiating functionality layer, and then depending on the industry that I'm in, it sits there for a few weeks, a few months, or a few years, and then it commoditizes and it becomes part of my commodity functionality layer. Are you still with me so far? Now, these layers need different approaches if you're in a commercial business. If you're in government, I think it's different, but if you're in a commercial business, here you want to optimize for minimal total cost of ownership. How do I keep this functionality running without spending any money on it, or spending as little money on it as possible? If it's differentiating, how do I optimize for maximum customer value? How do I really build it as rich and as valuable as possible? And then up here, because the success rate of innovation is relatively low, how do I run and try out as many different things as possible? That's how you should think about it. And then companies ask themselves a number of questions, like, and I go through this very quickly because I'm starting to run out of time. Yeah, so how do I expand my innovation funnel? I partner with my ecosystem. How do I get these innovations to market faster? Here I focus on speed. How do I know that what I'm building is delivering value to customers? Well, here I use data and AI. How do I identify that functionality is commoditizing? Again, data. How do I minimize total cost of ownership? I partner with my ecosystem. And then how do I organize for all of this? Empowerment. 5 dimensions, we're going to talk about that. The first dimension of the Stairway to Heaven is around speed. This is how we've worked with dozens of companies. All companies evolve through the same process.
Way too fast.
Really?
The last slide, I didn't get anything.
Good, that's fine.
You are brilliant with English, but we need time to consume what you say.
Okay. Skip the previous slide. Of course you get the slides. Yeah, you drop me an email. I'm going to talk about 5 dimensions. Yeah. This is how every company that I work with evolves. You start with traditional development. You have long cycles, 12 months release, 6 months release, but it takes a long time to get stuff out, and that's your heartbeat. The next step after that is you move to agile. You've all gone through your agile adoption of agile practices. The step after that is continuous integration. Still with me? You have your verification and validation department on board, and basically within a few minutes, hours, or days, you know that what you built is actually production quality or not. Once you have that, you can move towards continuous deployment. Who is doing continuous deployment in this room? 1, 2. Oh, okay, much more than I expected. Sorry?
Delivery or deployment?
Yeah, so I call, this is a big debate. In many companies go through a continuous delivery phase where they make the software available, but the customer has to decide when it gets picked up. For me, continuous deployment means that you decide when your customers upgrade. Yeah, so that's a little bit more tricky one. And you could have one in here that says continuous delivery and then continuous deployment, but I like 5. It's a good number. In psychology you have 7 plus or minus 2. Yeah, as to what you can keep in your head. I'm not too smart, so I'm more towards the 5 than towards the 7 and 9. So I keep it simple. Yeah, once you have continuous deployment, so your software is really deployed on a sprint basis, because that's my definition, that it goes out at least every agile sprint. Yeah, then you can move to what I call R&D's an innovation system. Then you can start to use your installed base for A/B testing. Yeah, what means if you have 100,000 cars on the road, You have two ways of building a feature. You don't quite know what is the right way of doing it. You put version A of the feature on 50,000 cars, and then you put version B on the feature on 50,000 other cars. You measure how this group of cars is performing, how this group of cars is performing, and then you look at the result and you decide, oh, A is better or B is better. Yeah, it's people here doing A/B testing. There are a few here. So if you want to know more, we work with Microsoft and Booking around these questions. Those companies run 2,000 to 3,000 A/B experiments concurrently in parallel all the time. According to the former CTO of Booking.com, Booking ran more than 30,000 A/B experiments during 2016. Yeah, so we have a whole model that goes from crawl, you do a few A/B experiments, to walk, to run, to fly. Yeah, so if you want to know more about that, come and talk to us. Why do I care about speed? Well, I recognize 6 feedback cycles. The development cycle, what is my heartbeat of development? My requirement cycle, how often can I reshuffle the prioritization of requirements? Quality assurance cycle, how often do I assess that I'm at production quality? The governance cycle, if I say that the 3 types of development, features, defects, and refactoring, how often can I rebalance those 3 different activities? How much resource go to that? Deployment cycle, how often does stuff go out to customers? And then my value creation cycle, how often do I verify that what I deliver to customers is actually delivering value? Still with me? With every step that I go up, I'm trying not to talk too fast, so yeah? With every step I go up, 1 or 2 of those cycles go from long to sprint-based. Can you see that? Yeah, that's why this thing is so important. And why do I care about going from long feedback cycles to short feedback cycles? Because in long feedback cycles, people take experience-based decisions. I've been with this company for 27 years. I know our customers and I know our product, and we're going to do this. And if you don't like it, you can go to hell. Yeah? Instead of, and when I'm sprint-driven, I can be, or sprint-based, I can be data-driven. Yeah, we think this is a good idea. Let's build a thin slice, get it out there, let's measure how it's used. If it's used, we continue going at it. If it isn't used, we basically drop it. Yeah, so then I can take data-driven decisions. This is, I believe, really important. Yeah, because how often have you been in a situation before you got to continuous integration where people ask you, how's the quality? And then you have to make some gut-based feeling like, we're not quite there yet, but it's pretty good. Yeah, that's the kind of answers that I used to get. Yeah, now you can basically say in continuous deployment, well, you know, over the last weekend we ran our 50-hour automated test suite, and out of the 30,000 test cases that we have, 29,950 passed, and we're now looking to the last 50 that didn't. Make sense? Yeah, so you can actually, now again, we've done work on architectural technical debt that I'm happy to go deeply into, and I know I'm in a room full of architects, but so I have to be careful how much I say here, but there are 2 things that are important here. The first is, not all technical debt is born equal. Some types of technical debt are what we call contagious. They spread through the system like a virus. Yeah, and what you need to do is, when you have to prioritize, typically this is bad APIs, for instance. Bad APIs tend to cause a situation that at the consumer side of the API, you do all kinds of things in order to deal with the bad API, and then that code is, other people are dependent on that code, and then what happens is that the consumers of what your consumer is doing are now starting to adjust to what they are doing, and what you get is kind of a spreading of a bad design decision throughout the entire system, and it's very costly to fix. That's the first thing. The second is what we call vicious cycles, and I will use a certain company in the automotive space that we have actually studied this. In this company, in the electrical system, which they call the hardware and software, electronics and software part of that vehicle, there were 3 ways for components to talk to each other. And the architect said, this is stupid. We should refactor the code so that we only use 1 new way for components to talk to each other. So you all know the story. They got the budget, they got the people, they did the work, they run out of time, they run out of budget, they run out of people, and they're not done. Today this company has 4 different ways for components in that system to talk to each other. So the problem is, you can do everything right, you can identify an important refactoring, you can get the resources, you can get the people, yeah, you can get the budget, and you can still end up in a place that is worse than what you started up with. Yeah, so don't do that. Yeah, that's my advice to you. The other thing that we've done a lot of work on, I suppose it is continuous integration of relevance to you. Yeah, we've developed something that we call the continuous integration visualization technique, which basically says that on the x-axis I have how often do I test and what is the what's the frequency of testing. On the y-axis I have the scope of testing. Is this components level, subsystem, partial product, full product release, or customer level testing? You with me still? In every space in every point in a two-dimensional space, I can put a box like this, where I have F stands for functional requirements, stuff that I'm building right now. Yeah, you all do test-driven development, right? As an agile practice, so you have those test cases. L is legacy requirements, stuff that used to work before I started to muck around in the code. Q stands for quality requirements, yeah, performance, robustness, etc., etc. And E stands for edge cases. We saw that almost every company has a number of test cases that do not really make sense, but they had to deal with a very complex bug at some point in the past, and they took them weeks to solve it, and now they have a test case in there to make sure that that error never slips back into the system, because it's going to take them forever to fix again. Yeah. We put color coding on this. The color coding for each of those small squares is coverage. So how much am I covering? Green means full coverage, orange means some, red means no, and the line around it indicates the level of test automation. Yeah, so green means fully automated, red means fully manual, orange means partially automated, partially manual. So this is a certain telecom company who I will not mention at this point, and this is several years ago. At that point, an individual developer would do test-driven development in his or her sandbox. Then it would go into the team branch. Yeah, some more testing would take place there. Then it would go to the single branch, and there was acceptance testing before the software was basically lifted into the test branch. Or in the main branch. And then that company had a 2-hour, every 2 hours they grabbed all the software that has been checked in, so all the software they had, they created an executable, and they ran all the test cases that fit in a 2-hour window. Every evening at 8 o'clock, they kicked off a 10-hour test suite fully automatically that basically grabbed all the code and ran a 10-hour test suite. And every Friday night at 8 o'clock, they kicked off a 50-hour test suite that basically ran over the entire weekend, and when you came back on Monday morning, you typically had a pretty good understanding of what is the quality of your software at this point. You still with me? Yeah? These kind of models are very helpful for you to model what is our current testing approach, what is our desired testing approach, and where will I get the biggest bang for the buck if I go and make changes to my test infrastructure. Yeah, because everyone here was talking about architectural technical debt management, but I have noticed that in many companies, the build system and the test system is not exactly pristine. Yeah, I'm not sure how it is with you. I hope it's a solid, automatic flow. No one has to spend much time on it, but that's at least what I'm experiencing. So this can help you improve that part. Continuous deployments. We talked about this. Basically, I have my internal continuous integration loop, and then I have a continuous deployment loop around it. And when I'm really good at continuous deployment, I basically collapse the loop, which means that every time anyone checks in code, it goes live very quickly. Yeah, this is how, for instance, Spotify works. The web player at Spotify deploys, I think, up to 25 times a day is, I think, what they're saying. Amazon claims that they release new software every 11.6 seconds on average, which for me is very fast. I don't know if there's business value there, but in any case. And what we see is that if you have a bunch of products that all are similar to each other, we see that companies are moving towards a continuous delivery model. That was that. That was speed. Are you with me so far? Or are you against me? There was one dimension, and I have 17 minutes left. Still good? You're hanging in there? Data. We have a similar path for data. You go from ad hoc to collection to automation to data innovation to evidence-based organization. Yeah, what does this mean? That collection, analysis, and reporting and decision making go from everything is manual to collection. When the collection of data is automated, but everything else is manual. I mean, whenever your car, since the late 90s, whenever your car goes to service, they basically put a big plug into it. They suck out all the data since the last service, and they send it back to the mothership. So every car company, for every car on the road, basically has all data that car has accumulated during its lifetime. You don't think much about it, but read the contract that you sign when you buy a new car very carefully. There is lots about data in there, actually, and it's only getting worse. Then you move to automation, then you get the dashboards. The problem with automation is that the dashboards tend to be static, they don't evolve. Then the next step after is data innovation. Yeah, there are especially mobile game companies that are very, very good at this. They have hundreds of millions of players. They have data analysts that are constantly looking for interesting patterns in the data. Whenever they find a pattern, they go to the relevant R&D or management team and they say, do you want this on your dashboard? And if the team says yes, then something gets kicked off the dashboard and this new thing gets put on the dashboard. So you now have dynamically evolving dashboards. Yeah, but it doesn't stop there. What I also see companies do is that they then put the data-driven behavior into the software. Yeah, so if you play a mobile game, and typically those mobile games are free, but you can do in-app purchases. Yeah, you can buy a gem or a diamond or something like that in order to help you solve stuff, right? You still with me? Yeah, so for a typical mobile app, 90% of CPU cycles goes to analyzing player behavior. So if you're playing a puzzle game, for instance, the first analysis that starts is this player stuck at this level in the game? And if the analysis shows that you're not stuck, then it will there stop. But if it looks like you're stuck, it goes to the second analysis. And the second analysis is, how likely is this player to buy a little item from us in order to help that player get forward into the puzzle game? Yeah, if we just let the player suffer for a little longer. And if it turns out that you're, based on millions of other players, that it turns out that you're likely to buy a gem, the game will do nothing. So it will just let you suffer. Yeah? But if it turns out that you're not likely to buy a gem, the third analysis starts. And the third analysis is, how likely is this player to buy a gem from us at a later stage in the game if we just help the player to get there? And if it turns out that you are likely to buy a gem later but not right now, the game decides to give you a free gem. How cool is that? That's cheating, I can see everyone say, right? Now it's running a business. Yeah, that's how you make money. Now, a more ethical use of data. Why do you use Spotify? Most people don't use Spotify for the music. They use Spotify because they find music through Spotify that they would have never found otherwise. Yeah, and how does Spotify do that? They look at people, their listening behavior, and then they look at people that have similar interests as you. They help then you find the music that these other people are listening to that you haven't found yourself yet. Yeah, that's perhaps a more genuine use. The final one is the evidence-based organization. Then everything in the company is data-driven. Yeah, so when I worked for Intuit, my friends at Google told me how performance evaluation goes at Google. Your boss has nothing to do with it. Basically, 6 people are asked to evaluate you, 3 from the same team and 3 from other teams that you partner with. And as part of their evaluation, these people have to give 3 names of people that perform less good than you, 3 names of people that they think perform as good as you. You can see where this is going, right? And 3 names of people that they think perform better than you. Now, if you, for every individual in the organization from 6 different sources, get 9 different names, it's very easy to calculate a rank order from the most valuable employee in the company to the most useless piece of human being in the company. And then salary increases and bonuses and everything else just become a mathematical formula, right? Not everyone is equally enthusiastic here. I don't know why. Sorry?
Will you start hiring bad people?
To make yourself look better.
Yes.
Yeah. That's an interesting approach. That's a very interesting approach. Okay, we're not going to go into that one. I need to start talking faster now. Sorry. I mean, the second part of this presentation is not for you. Why do I care so much about it? Our data shows that roughly between half and 2/3 of all the features that get built are never used or used so seldomly that the R&D effort that was invested in them was not worth it. Yeah, so every company I walk into, I basically tell them half your R&D is waste. You just don't know which half. I can help. Yeah, and we did our own research in Gothenburg with a company that shall remain unnamed. We see exactly the same pattern. Some features are used a lot, some features are used occasionally, and many features are never used. Now, let's be clear, some features are not intended to be used very often. My car has an airbag feature. which I hope will never be activated, at least not while I'm an owner of the car, right? But for the features that are intended to be used by customers on a continuous basis, these are the numbers that we find. Yeah, so one of the questions, one of the models that we've developed is what we call the Pecks model, where we basically say, before you build a feature, let's first agree on how will the behavior of our customer or the behavior of the system change in measurable terms that justify building this feature. You with me so far? Yeah? So what will change that justifies building this feature? Then I built the minimal viable feature, the first 10-15% that I believe delivers the most value. Yeah, this is a bit of a bad term. In startup community, this is now called the MLF. You know what it stands for? The minimal lovable feature. How cool is that? Yeah. So I get that out, the first 10-15% with instrumentation. Now I get the actual behavior back. So now I can measure what really happened. And then I get into a gap. If I see that there is no movement whatsoever on the things that I expected to happen, I should just abandon the feature. Get even the 10-15% out of the system, because clearly the feature is not adding any value. Imagine that I've built 30% of the feature and I've gotten all the effect that I'm looking for. Then I just stop developing. I can just move on to the next feature. Why build the rest? Yeah, and maybe I have to extend the feature a little further and I keep extending until I plateau in terms of value delivery. Or I look at the data and I realize I've built the feature wrong. This is not how people want to use it. And then I should drop the existing implementation and move to a different realization of the feature. So what we see is that companies are moving to 3 types of development within the same system. We have what we call traditional requirements-driven development. Product management throws requirements over the wall. You build it, you're done. Yeah? The second is outcome-driven development. A team at Booking will never see a requirement in their life. What they will get is quantitative output metrics like conversion. Imagine that you're responsible for part of the website with your team. Conversion for your part of the website is 3.2%, so 32 out of every 1,000 people do what you want them to do. And your goal is very simple. For the coming quarter, get conversion from 3.2% to 3.4%. And how you do it? That's entirely up to you, dear team. Figure it out. Yeah? And you can go and run A/B experiments. You can do a fundamental redesign of the website. You can go and interview customers. You can do all kinds of things. But your measure of success is, did you move the needle? You with me? Third type is AI-driven development. Then I have large data sets. I can train machine learning and deep learning models with those large data sets, and I can deploy the AI components. And a typical system in the future will have these different types of components, and will have continuous deployment of each of those components, and will have continuous performance data coming back from these components that show you how well each component is doing. That's how I envision the future. Now, I don't want to spend time on this because I'm way behind schedule as it is, but Peltarion, take a look at them. They do pretty cool stuff. They do all kinds of things, from predicting energy production to house price evaluation to cancer treatment to etc. Yeah? What I think is important for those of you experimenting with it right now, this is a paper from Google. The machine learning code is the little black box in the middle. All the other stuff are solutions that they need for this little box to work properly. AI does not free you from the obligation to do proper engineering. Yes, I know. We did research on this. There's a paper that I'm happy to send to you, which basically says that if you look at effort estimation, the cultural differences, glue code, etc., there are all kinds of really hard problems. I mean, the most fun one, I think, is effort estimation. Imagine you go to the business side of the house and you say, hey, we want to try out a machine learning technique for this problem, or we want to build a machine learning technique for this problem. And then the business side asks, how long will it take? And your answer is, I don't know. How much benefit will it give? I don't know. Yeah, how successful do you think? Or how long is it going to take? I don't know, right? So you get into a situation where you don't know how much it's going to cost, you don't know how much benefit it's going to give, and you don't know how long it's going to take. And you still want them to fund the initiative. Good luck on that one, right? Yeah, so we see lots of these kind of challenges in working with machine learning, deep learning. 2 topics still, and 7 minutes. Empowerment. I'm not sure, does anyone recognize this? Yeah, so the funny thing is, in my experience, most people that are C-suite or senior leaders laugh at this graph, and the people that are at the bottom laugh at this graph. The people that are in the middle don't laugh about this graph. I don't know why that is, but let's not go there. What's that? Oh, you were laughing. And you're a middle-level manager? Yeah. We see that companies move from traditional to agile to cross-functional, self-managed and empowered. Why do I care so much about it? I'm going through this very, very quickly, so I have a few minutes for questions at the end. Hierarchies are very good at a number of things. Scaling, controlling many people from a central position, efficient for repeatable tasks, harmonization processes, globalization, handle low complexity situations well. They also suck at a number of other things. Oh, you have to cut that out. I shouldn't use that word. They are also pretty bad at other things. Yeah? Slow decision-making processes. Power is driven by position, not by capability. We've all had experiences with really bad bosses, I'm sure, right? Tendency to be internally focused. Easily gravitates to politics. Highly resistant to changes and challenged by high complexity situations. And with a constantly accelerating world, hierarchies are just not the right answer. And we can see this because if you look at US employee engagement in 2013 and 14, around 30% of employees is engaged, around 50% of employees is not engaged, and around 18% of employees is actively disengaged. You know what it means? They hate working for the company so bad that if they can do something to damage the company and get away with it, they will do it. Yeah? If they're in office early and no one is there, they will kick the printer and hope that it breaks. Just say, oh, I don't know, it was like this when I came in, you know. If I'm a truck driver, I will dump electronics very aggressively in the back of the truck because I just hate working for this company. And now I can see all of you think, Jan, this is a US company, of course. What do you expect? Europe is much better, right? Right. Here are the Swedish numbers. 16% is engaged, 73% is not engaged. And the only good news is that only 11% of employees is actively disengaged. And the other interesting thing is the younger you are, the less happy and the less motivated and the less engaged you are in a hierarchical organization. We need a new model for organizing companies. Now, I don't have time to go into this, but Agile is already a first step on the road. There is a book that you can download for free called Reinventing Organizations by Frédéric Laloux. He will basically allow you to download the book, the electronic version, and then a few weeks later he sends you an email. Now that you read my book, why don't you send me a few dollars? Pretty reasonable request, right? So he basically says we're moving to holistic organizations where there are no bosses, and he describes 27 cases of companies without bosses. Holacracy is a model from the US developed by an agile development person. Exponential organizations describes how companies like Airbnb and Uber can grow so incredibly fast with very few employees and other things. But we're really moving towards a model where we go from principles over orders, personal leadership over leader-follower, trust over audits, customer first over organization structure first, team-appointed managers over manager-appointed teams. I like that one. Diversity over homogeneity, agility over long-term planning, and emergent strategy over top-down strategy. Yeah? The world is really changing. We can see, and I believe that the Scandinavian countries are uniquely suited for experimenting and finding new ways of organizing our larger organizations. Yeah? Go ahead.
Holacracy. Do you know any successful companies or any companies successfully employing Holacracy?
Yeah, so that's an interesting one. Zappos adopted Holacracy. Zappos is a shoe e-commerce company that was bought by Amazon a couple of years ago. They lost around 10% of their employees, people that refused to work without a boss. I believe that initially it worked quite well, but more recently I've heard some rumblings. So I don't know the details of that. I haven't looked into that recently enough. But you have heard things that are not so positive.
I've only heard it at an academic level. I wasn't
Right.
aware that it was actually being
No.
used
So
on big scale.
So, I mean, now I'm out of time, but
Sorry.
this book describes 27 companies ranging from dozens of employees to tens of thousands of employees where there are no bosses. No one has a manager. So it can be done. It can also be done at large scale, which I think is quite interesting. So take a look into that. Finally, ecosystems. I'm almost done, guys. I know that I'm the only thing in between you and lunch. Why does it do this? Okay, sorry. There is a company goes from being extremely internally focused to being externally focused. Do you remember this model that I shared in the beginning?
Yes.
I've now asked well over 50 companies, what percentage of your R&D goes to commoditized functionality? And what percentage of your R&D goes to differentiating, innovative, and experimental functionality? What do you think the answer is? The answer is that somewhere between 80 and 90% of all people in R&D in a typical company work on commodity functionality. So the state of software today is then in a typical organization, 8 or 9 out of every 10 work on stuff that no customer gives a flying hoot about. It should just work, not differentiating. And the 1 or 2 that build new stuff, they get it wrong half the time. That's where we are. I believe that there is a slight room for improvement. Not sure if you agree on that, but that's at least what I believe we can still do. Yeah, but take that away from this. 8 or 9. So look at the table where you're sitting. You are the only one who does differentiating work. Everyone else is working on commodity. Yes. Yeah, so that's where we are. We worked on what we call the 3-layer ecosystem strategy model that I will not bother you with, except that there are several strategies that we have studied that companies are employing for reducing the amount of resources that go to commodity functionality and free up resources for differentiating and innovative functionality. If you want to know more, you have to come and talk to me afterwards. Conclusion, you know who this guy is? No, no one knows this guy. George Colony, CEO of Forrester Research. In the future, all companies will be software companies. If you're a bank, you're really a software company with a few offices attached to it. Yeah, if you're an insurance company, you're really an a software company with a few offices again connected to it. I mean, if you're a clothing company, Zara and now H&M is working really hard in catching up. It's really the software-driven supply chain which differentiates a successful from an unsuccessful clothing company. If you look at companies like Ericsson, they are pure software companies. The amount of investment in hardware and electronics is tiny. According to Volvo Cars, 80 to 90% of all innovation in a car these days is driven by software. Yeah, so all companies that you think of as logistics companies, car companies, banks, insurance companies, whatever, they're all software companies. Yeah? Digitalization is a big thing. You need speed and data, AI, empowerment, and ecosystems in order to be successful. And you know, here we go. I wrote a couple of books. This is a bigger one. It's around 300 pages. And I signed away the IP rights to CRC Press. So I can't give this one to you. But these two, if you drop me an email, I sell those for $9.99 at Amazon.com, yeah, electronically. But because I love you guys to pieces, if you drop me an email at jan@janbosch.com, I will send these books to you for free. Free as in beer. Huh? Not bad, eh? And with that, my friends, thank you very much for your attention. I'm sorry I'm a few minutes late. I'm sure we can have a few minutes for questions.
Yeah, sure. So,
Any questions? Any remarks? I cannot be here this afternoon, so if you want to talk to me, this is the time, because I need to get back to Gothenburg, because it's spring or fall break and I have kids at home. Actually, one kid right now. Sir?
There's something called GDPR, which tends to have a very large impact on companies in terms of what changes that needs to be carried through.
Yes.
Do you believe if you have a holistic or whatever company structure, that you would actually get to implement all of that? Because everyone has their own personal pet projects that they rather do than this boring GDPR.
Yes. Oh, are we talking about the implementation of GDPR or the impact of GDPR on...
So you don't want all the fines and you don't want to shut down the company and all that? So
No. Yes, I mean, basically that is a prioritization question within the company.
Yeah.
And why I believe that it's so important that we have a holistic management in the organization where IT and business are not two ends of are not two different camps that basically typically get into fights when they are when it's planning season or when it's prioritization season. I mean, you need to together figure out what is work that needs to be done. But I do want to make one side note on GDPR. I work with a few companies that have chief data officers. Yeah, and these chief data officers, you need to ask them for approval to collect data. And in this German company, the chief data officers only have one answer to every request. It starts with an N and it ends on O. Yeah? Which is, of course, a really stupid way of going about it, because it's clear that the world is moving to becoming data-driven. So the question is not, we shouldn't collect any data. The question is, at which states in the pipeline do we anonymize the data to the point that we are no longer violating GDPR? And how long do we keep the non-anonymized, and how do we deal with the non-anonymized data? That's the big question, of course, that many companies have to answer for themselves. And I think that the business side often is so stuck in the business of the past that they don't see the value that is now happening. Yeah, that is now being created through data. It's really happening now, yes.
So if every company is actually going to be a software company in the future,
Yeah.
how would it affect the division right now between the business side and the IT side?
Yeah, so that's the point. I don't believe that any company that doesn't have a very tight integration between business and IT can be successful in the future. Because basically if IT and the business side only meet at the CEO level, yeah, where I have the CIO here and I have all the business heads on that side, then all the opportunities that IT gives, yeah, all the things for using data to your advantage, using AI solutions to your advantage, I mean, then the business side, if you have to wait for the business side to request development from IT, which is the case in many traditional IT companies, then you're dead. I mean, you're the walking dead. You're still breathing, but you're not. I mean, soon, yeah. But that's what I see in many organizations. I mean, you have to bring those things together. It needs to be an integral part of a company. And I see this. I mean, if you look at Volvo, almost. If you look at Volvo Cars, if you look at Ericsson, if I look at several other companies in Software Center, this is starting to happen. Yeah, product managers and R&D are in the same team. They're now becoming, at the ground level, they're starting to become part of the same cross-functional feature teams.
Does it make sense for you to be on the business side if you don't have any idea about software development or digital technologies in general? What does it mean to be a business? I mean,
Yes.
I don't understand that. I'm trying to advocate some of that. Some of those views in my company, and I'm getting,
you're getting shut down. Yes. Yeah, no, I understand, because
telling people if you don't understand IT, get out of my.
yeah, because most of the people that sorry, yes.
What business do you have in software if you don't understand business? I think we, as architects and parts of the tech organization, we spend a lot of time and energy on all the knowledge that they don't have on the business side and all the ideas that we could feed them. But just that we have a guy or a few here suggesting that it's a good idea to hide technical debt within feature development and not let the business be a part of the prioritization.
Yeah.
Is really good, illustrates very well that we also need the information to go the other way.
Yes.
There is no other way. There's only one way. That's my point.
Yeah, and what I see is, I mean, business models are shifting, huh? I mean, basically, if I look at automotive, I used to buy a car every 5 years or every 8 years or something like that. Now the plan is that if I get mobility as a service, I go from a transactional model to a continuous model where I basically have a continuous relationship with my customer. I see the same in telecommunications. In telecommunications, it's more and more a services business that we are in the midst of, and I think that that's true in almost every industry. And then the business models can start to change. I recently heard about a company that was selling its physical products below the cost of production, because they were able to collect all the data that came from those products. That was part of the deal. And they were able to monetize that data to an extent that they could actually sell their physical products below cost price. Yeah, those are the kinds of business models that we now see change. Now, if you are in a business where you are selling physical products and that's your only monetization strategy, how do you compete with a company that sells below cost price because they have alternative ways of monetizing? Can you see that? It's tricky. So there is a lot happening. That's why we see so much disruption in industry. Yeah, on average, a company lasts 10 years on the Fortune 500. Yeah, because we're not changing. And once again, and I will end with this because I know that you have to go for lunch. Sorry about that. Architects, for me, live on the interface between business and technology. You are the ones that have to identify the opportunities and then go and evangelize and advocate on both sides of the fence, because in most companies it is still a fence, yeah, on both sides of the fence, what is happening and how this, and then find the right words to convince the business folks, and still have the technical chops to convince the R&D folks. That's your job, where I come from. And with that, my friends, enjoy the rest of today and make sure that you deliver the skills that you need in order to be successful there.
Good stuff.
Yeah? Thanks. Sorry.